Domain and ranges. Let's talk a little bit about domain and ranges. Whenever we're solving for a domain of a function, we are looking for its restrictions. Okay, and what do I mean by that? I just mean, what is it going to cause it to not be a real number? You know, if it's not going to yield out a real number, then it has restrictions and our domain is built around that. So our domain is what's going to give us the real numbers. Okay, so let's look at the example one right here, the first one we got. We have a function called f, and it's f of x is equal to 5x plus 2. And let's just talk just a second about functions. Functions is, it could be called f, h, j, k, whatever it may be. It's going to be of x, and it's always going to equal y, right? So that's a function. So let's look at it. What I have a polynomial. I have 5x plus 2. And I could have had 5x to the 7th plus 2x to the 5th plus 10. I mean, it could have went on and on and on. But if you notice that this polynomial, it doesn't matter what I plug in for x here. It's not going to matter. Even in that one I had just written up right here, it didn't matter what I plugged in for x. I plugged in a negative value, a positive value. It doesn't matter. It's still going to end up giving me a real number. So therefore, the domain on this polynomial is going to be real numbers. So it's going to be a negative value to a positive value, meaning negative infinity to positive infinity. Means anything on this number line here, right? And so on, is going to yield out a positive outcome. So it's all real numbers. It can be written like this, or it can be written as negative infinity, infinity. Did you notice though, I used parentheses here. The reason why I use parentheses says that we're approaching that point. So that means that we cannot ever stop infinity. So you need to always put a parenthesis on infinity. You would not put a bracket, because a bracket tells me you're going to stop at that point, and infinity tells me we're going on forever. Well, let's look at example 2. Well, if you notice, example 2 is a fraction. So in a fraction, there is going to be some restrictions. And how come I know that is because there's a rule. In the denominator, and I'm going to write it like this. In the denominator, you cannot have 0. You cannot have some kind of root. You can't have a negative number. Can't have a fraction. Can't have a decimal. Can't have an imaginary number. However, if you have a root or a negative number, fraction, decimal, imaginary, we can work with those. There's a mathematical rule that we can apply that would undo all that. But 0, 0, there is no rule. If you come out with a 0 in the denominator, then it is an undefined fraction. Therefore, it's not going to yield a real number. So what we need to focus on is the denominator to determine what's the domain. So I'm going to take the denominator and I'm going to set it not equal to 0. Why did I say not equal to 0? Because if it equals 0, then that means this is not going to yield a real number. Therefore, we have an undefined function. So let's solve for this. Well, what I need is my x value to be on one side and my constants on the other. And guys, you can add this x to both sides because the x is already negative if you want. It'll make it easier. And that gives me 4 cannot equal x, because if 4 equals x and I plug it in, then I have 4 minus x, then that gives me 0. It's undefined, so it's not real. Or some of you may say, oh, I want to move the 4 to the other side. Well, since 4 is positive, we need to subtract it from both sides. And now I got negative x equals negative 4. However, the coefficient on x has to be a positive 1. It cannot be a negative 1. So I'm going to divide by -1, and I get +4. So either way we go, we came out with the same answer. Both options are correct. All right, so now I know that x cannot equal 4 in order for this to be real. So whenever I put this on the number line, I'm going to plot my 4 right here. I got my infinities and negative infinities. This tells me that from, and I'm not going to touch 4. I'm going to do my best not to touch it. I'm going to try to get close to it. All the way out to negative infinity, I could use, because I mean, we can plug in 0, and that gives me 4 minus 0 is 4. We can have that. I can plug in -5, so that's 4 minus -5, which is going to be 9. I mean, I can have that, right? So I can have all numbers less than 4, and then I can have all numbers greater than 4. Whoops, I'm trying not to touch that line. It's kind of a little hard right there. I can have all numbers greater than 4. So basically I can say 4 minus 5 gives me -1. Well, if I had a negative in the denominator, I'll just bring the negative to the front, and that means x plus 3 over 1 would just give me a negative in front of that fraction. I'd apply it to each part. So, I mean, that's going to yield a real number. I mean, really. So basically, I can have all points smaller than 4 and all points greater than 4. However, I cannot have 4. So my notation on this would be an open circle on this point on the graph, and it's going to be a parenthesis. So when I write this out, I know that you always put a parenthesis on infinity. So, and you always read left to right. Always read left to right, but smaller to larger. So I have negative infinity to 4. I'm going to put a parenthesis on 4 because I'm telling myself I'm approaching 4, just not including it. And then I'm going to say it's going to union, right? It's going to union all points on the other side of 4. And that's what that is saying. So my domain here is negative infinity to 4, union 4 to positive infinity, and we didn't include those points. Okay, so let's talk about another example. Well, let's talk about a graph now. Now that we're talking about the graph, I can actually tell you the points, the range, and the domain. So whenever we're talking about domain and ranges and we're looking at a graph, what we can do, let me get this back on the screen, is determine where is the line, where is the function at. If you notice, it's right here. Whenever we talk about domains, we talk about its x values. Whenever we talk about range, we talk about the y values. So let's state with the domain. Well, anytime we're solving for the domain, we always read left to right. Okay, so that means we're going to start right here and we're going to move all the way across to the right. But when I start right here, what do I see? I see this line has an arrow on it. That arrow tells me that it's going to continuously to keep going on and on and on. So I know my domain is going to start out with a negative infinity. So I'm going to follow this line out. Where does it go? It goes on. And down here at this end, it has an arrow. So it tells me it's continuously to go on. So it's positive infinity. So, I mean, this is all real numbers. Okay. Now let's look at the range. Whenever we look at the range, we always read bottom to top. And if y'all notice, we're always starting with the smaller numbers and going or working our way up to the larger. So our range is going to be right here. We're going to start right here. And when I do this, I'm going to go up to where I hit the line. And I notice it hits right here at 3. And I'm going to put a bracket. Actually, I would put a bracket on it if it had a closed circle there. But in this case here, it's a solid line. And what does it tell me? I can't go any further up. It's actually just staying on that right there. So this has this, it's not a bracket, it's a parenthesis, a brace. And it's going to be at -3. This tells me that this range is happening only at -3. However, I just wanted to take a minute and draw one so I can explain what its domain and range would look like. So if I had, say I had something like this going on, and let me draw it just a little bit better and make it easier to make our statement at, and draw it a little bit better. All right, let's do this. And let's do a dot. I just kind of wanted to give you an idea what I meant by dot. And later we'll talk about piecewise. That's when we have more than one function with something happening. It breaks into parts. We'll talk about those another time. So let's talk about its domain and range. All right, so let me clean this up a little bit so we can see it. So whenever we talk about its domain and range, well, domain's the x value. So I'm going to start right here on the left-hand side and work over. And I notice that there's a closed circle right here, and it's at -4. So my domain has a bracket at -4 because it included it and it did not go any further. If it was an open circle, that'd be different. But this is a bracket closed circle. We're going to follow this out, and you notice the other end of it has a arrow. So that means it's going to be an infinity. And I'm going to put a parenthesis on it. Now let's talk about the range. So the range, and I was just doing the shorthand notation. Let's do shorthand notation. So we talk about the range, and we move up from bottom to top to find it. And if you notice, it hit right here at 3, right? The belly of it hit right here at 3. And we're going to look. Well, what I see going on is one end has an arrow and the other end has a closed circle. However, they're both going up, So we have this bracket here at 3 because it included it. It's not doing anything else. So my bracket is at +3. However, since we have this open or this arrow here, that means we are consistently going on. So we're going to include that infinity sign. However, if it's a closed circle, then we would pick the highest one out of the two. In this case here, we have the arrow, so we're continuously going on. Now, let's talk about a function called g. And let's state what is its domain. Now, if we graph this, we can determine its range, but right now we're just talking about its domain. And if you notice, it is an even root. What do I know about even roots? Even roots cannot have a negative number in the radicand or in the radical. The radicand is actually what's inside the root. So if it's an even root, you cannot have a negative number inside there. That's telling me that you can multiply something an even amount of times and come out with a negative answer. That's not true. If you multiply negative times negative, you get a positive. No matter how many times, as long as it's an even amount of times, it's always going to be positive. So this is why. So there is a restriction on even roots. So what we need to do is take what's inside there, the radicand, and what we're going to do is set it equal to or greater than 0, meaning that I can have 0 in the root, because the square root of 0 is 0, cube root of 0 is 0, fourth root of 0 is 0. Okay, so that's all true. So what we need to do is figure out where is this even root restricted at. So what I'm going to do is start solving for x. So since 6 is negative, I'm going to add it to both sides because I want it to go away right here. Now I have 2x is greater than or equal to 6. So I need a +1 coefficient on x, and I have a +2, so that means I'm going to divide by 2. So now that gives me x is greater than or equal to 2 divided by 6 is 3. So this tells me, so let's draw this out on a number line. I'm going to plot my 3. This says x is greater than 3. So we're going to go off in this direction, go off to positive infinity. And we are including 3 because it says equal to. So that means that its domain is a bracket 3 to positive infinity. Now I want to take a second and I want to just introduce something just in case you have forgotten this. What if the radicand was a negative 2x minus 6? What if it was like this? Then I'm going to take that negative 2x minus 6, set it greater than or equal to 0. Again, I'm going to add the 6 to both sides because I want the 6 to go away. And it leaves me with negative 2x greater than or equal to 6. Now, this is an equality sign. All right, whenever you talk about greater than or equal to, you talk about equality sign. I need a +1 coefficient on x, and I got a -2. So that means I'm going to divide by a -2. Negative divides negative is positive. But whenever I force the negative sign across an inequality, that means we got to flip the inequality. Now, -2 divides -2 gives me +1. -2 goes into +6, gives me -3. So now when I draw it on the number line, I am saying that x is less than -3. So we're going off to negative infinity. And it is equal to the -3. So we got a bracket. So I got parentheses negative infinity to -3 bracket. So it is important to pay attention to the signs and what we're working with. So let's talk about our next one. Well, the next one is a odd root. See it? It's a cube root. It's odd. It could be fifth root, seventh root. It is an odd root. That means odd roots has no restriction. Whoops, kind of got a little messed up there. But anyways, has no restriction, meaning that I can multiply something an odd amount of times and come out with a negative answer. Right? That's a negative. I mean, it doesn't matter. And I can multiply something an odd amount of times, come out with a positive answer. So my answer that comes out of here can be negative or even, whatever's inside there. So whatever I plug in for X, it doesn't matter. I'm going to always yield a real number. So its domain is negative infinity to positive infinity. The domain up here is restricted because whatever I plug in for X here, it has to yield a positive answer that's inside there and the outcome. So whatever my answer is, I can plug it in. So I got 2 times 3 is minus 6 gives me what? 6 minus 6, which is 0, and that's okay. However, if I was to go the other route and plug in a negative 3, what do I get? Negative 6 minus 6, which is negative 12. Well, the square root of negative 12 is not real. That is an imaginary number. So this is why it's important that you determine what the domain is. Let's look at this next one, this next graph. Let's state the domain and range. So we have a parabola going on. And if you notice, the parabola does not have arrows on the end of it. It just has a closed circle. So that means we're stopping at specific points. So let's state its domain. Well, the domain, we read left to right. We notice, it's on the y-axis. So I know that it's going to be 0 for X right here, right? And then since it's a closed circle, it's equal to, and then it's going to keep going. And then it's another closed circle, and for X, it's 8, and it's a bracket. So this tells me that my domain is in between 0 and 8, and it includes those points. Now let's look at the range. Range, we start at the bottom, work our way up. Oh, what do I see? I see a negative 3 that we're including, and I keep going up. Now, one of these lines could be higher than the other one. It doesn't matter. We're going to stop at the longest line. Well, in this case, they're both on the same. So it worked out great. And it shows that my Y value here on that is 1. So, and it has a closed circle. So my range, which is Y values, is negative 3 to 1. Now let's talk about my last example of domain and ranges. Let's talk about a circle, and I meant to have you a graph there and I did not. So let's just take this right here and let's move it down here. And let's talk about a circle. What if that was completely connected? And let's see if I can draw it good. Let's draw. Okay, the domain and range of a circle. Well, again, the X values is read left to right. And what do I see? 0 for my X value here. And then 8 for my X value there. And they're both closed. Now let's talk about the range. Well, we're going to look here at the Y value. So my range has a Y value of negative 3, and it's included. And we're going to follow it out. And it appears to be at positive 5, and that is my range. So that is talking about domains and ranges of functions and graphs.